It's important that algorithms solve problems in the most efficient way possible. This means that algorithms use as little time and memory as possible. But how do we measure this? We can't measure exactly how many seconds an algorithm runs for, or exactly how many bytes of memory are used. Instead, we use something called time and space complexity. These tell us how much time or space is needed relative to the size of our input data. Let's look back at the algorithm we looked at. We need to consider how much memory and time this algorithm is using. Let's start with time. If the input array is size 8, like in this example, this for loop over here would loop 8 times. If the array was size 5, the loop would loop 5 times. And if the array was size n, so any size, the loop would loop exactly n times. In this case, we say that the time taken as a function of n, or t of n, is just equal to n, meaning input size and time taken has a linear relationship. Thus, we say that the algorithm has a time complexity of O n. But no matter how big the input array is, the algorithm only ever defines 3 variables, I, odd, and even. These variables then takes fixed portions of memory. Since these portions of memory are the only memory used, we say that the space complexity of the algorithm is constant, or just denoted as O of 1. When finding time and space complexity, it's useful to draw the truth tables for the algorithms so you can visualize how many iterations it takes for different input sizes. These are some of the possible values for the big O notation. Each big O notation represents a different relationship between the input size n and the time taken Tn, or the memory used Sn. But one important note is that Tn and Sn aren't actually time and space complexities. It's the big O notation that you need to write. So even if you find the relationship in an algorithm between time and input size to be T of n is equal to 2n, for example, you still need to write your final time complexity as big O of n. Because the coefficients don't actually matter for time complexities and space complexities. It's all about the overarching relationships.